Welcome to clickmydesire.com. Let me discuss the project about automatic dynamic texture segmentation using local descriptions and optical flow. In this paper, we propose a new method based on both appearance and motion information for the segmentation of dynamic textures. For the appearance of dynamic texture, we use local spatial texture descriptors to describe the spatial mode of dynamic texture. For the motion of dynamic texture, we use the optical flow and local temporal texture descriptors to represent the movement of object and imply the histogram of oriented optical flow. Approach to organize the optical flow of a region. To compute the distance between two histogram object optical flows, we develop a new distance measure based on the Weber's law, which is simple and efficient. The modifications are very useful to employ both the appearance and motion modes for the dynamic texture is that dynamic textures might be different from either spatial mode, appearance, and or temporal mode. The motion field combining the spatial and temporal modes, we explored the use of discriminant features of both the appearance and motion for the repose segmentation of clustered dynamic textures. It's the block diagram of our project. First we will load video. The next one is frame conversion. Videos are converted into the frame. The next one is pre-processing. Then Gaussian filter will be applied for input frame and load video images. The next one is binary segmentation. Binary segmentation is the images segmentation is the process of part of digital image into multiple segments set of pixels, also known as superpixels. The goal of segmentation is to simplify and change the representation of the image into something that is more meaningful and easier to analyze. The image segmentation is typically used to locate the objects and boundaries in images. Then this more persistently, image segmentation is the process of assigning a label to every pixel in an image such the pixels with the same label share certain visual characteristics. The next one is hierarchical splitting. Hierarchical splitting is the recursively split each input frame into square regions of varying sizes. Here a necessary prerequisite for the following merging to be successful is that the individual regions are uniform in texture. To do this task, we use the following criterion to perform the splitting. If the appearance or motion modes for splitting of the current region, we perform splitting. This splitting procedure is repeated recursively on each sub-region until none of the regions in one frame satisfy the criterion or the predetermined minimum patch-wise sizes of this hierarchical splitting process. The next one is agglomerative merging. This merging is the after the input frame has been split into patches of roughly uniform texture, we merge these similar adjacent regions patches until a stopping criterion is satisfied. The merger importance in algorithms minimal these regions pairs which satisfy the conditions. The similarity between these two regions is larger than the threshold. The appearance and motion similarity between two regions computed in these functions, these pixels in the similar one to two regions, it is computed to this number of pixels in the smaller one to the two regions. Then this each moving into the next merger, we compute the feature of each region by accumulating the histogram of LPP and LPW for the histogram optical flow of two merged regions. The next one is texture segmentation. Texture segmentation is the pixel-wise classification. We perform the simple pixel-wise classification to improve the localization of the boundaries. To this end, we switch into this dynamic texture classification made by using the appearance and motion features. Top histograms is of these frame segments for the dynamic texture models. In our implementation set, these values follows the same rules. It's that the splitting and merging here they are performed in dimensions and frame by frame. During the splitting merging steps, both the spatial and temporal features of the dynamic textures are employed. Specifically, the appearance of dynamic texture is described by a local spatial texture descriptors. The temporal features of the dynamic textures, the motion's dynamic texture during the segmentation is described by the histogram optical flow and local temporal texture descriptors. Now let's see about the execution part. I am having background main.m file. Then select the file, right click, then run file. Then here we have to select the automatic dynamic texture image segmentation. And first of all, you are select the load video. Then here we have to select the input video. Then this one is loaded video. The next one is frame conversion. Totally 30 frames are converted into the video. The next one is binary segmentation. Then here we have to select the any one of the frame. Then this one is frame. The next one is noise removal process. Then Gaussian filter will be applied for input images. The next one is binary conversion. Then noise removal process is applied to the binary conversion in black and white images. Binary conversion is the image segmentation is the process of part of digital image into multiple segment set of pixels, also known as superpixels. The goal of segmentation is to simplify and or change the representation of the image into something that is more meaningful and easier to analyze. The image segmentation is typically used to locate objects within the boundaries in the images. The next one is select the splitting process. Then this one is hierarchical splitting. Hierarchical splitting is the using the features accumulator mergings and the pixel wise classifications for this hierarchical splitting process. Hierarchical splitting process is very useful to this recursively split each input frame into square regions of varying sizes. For this necessary prerequisite for the following merging to be successful is that the individual regions are uniform in texture. To this task we use the following criterion to perform the splitting. The next one is pixel-wise segmentation. Pixel-wise segmentation process is very useful to perform the simple pixel-wise classification to improve the localizations of these boundaries. Through this end we switch into this dynamic texture segmentation mode by using the appearance and motion features. Top histograms of this histogram optical flow imaging. This one is pixel wise segmentation process. Then this one is edge based segmentation. Then this one is blurred images. This one is edge-based segmentation. Edge-based segmentation is this running the segmentation tool of dynamic texture. One can have two observations as the following: if two neighboring patches belonging to the same texture categories. Then this one is pixel-wise image segmentation. The text is basically the appearance of dynamic texture is described by a local spatial texture descriptors. The temporal features of the dynamic textures during the segmentation is described by this motion of dynamic texture. During segmentation is described by this histogram optical flow and local temporal texture descriptor. Then next one is texture segmentation. Texture segmentation. This one is texture segmentation. Texture segmentation process is the very useful to generated at the extension of the texture to the temporal domain. Then segment the dynamic texture challenging problems in this work. We address the problem of segmenting a dynamic texture into disjoint region. A dynamic texture might be different from its spatial domain mode and temporal mode. To this, we develop a framework based on the appearance and the motion nodes. For this appearance mode, we use a new local spatial texture descriptor to describe the spatial mode of the dynamic texture. Then this for the motion mode, we use the optical flow and the local temporal texture descriptors to represent the temporal variation of the dynamic texture. In optical flow, we use the histogram of oriented optical flow to organize them. To compute the distance between the histogram optical flows, we develop a simple, effective and efficient distance measure, and based on these addresses of this pixel-wise image segmentation is developed to the texture segmentation method offline supervised statistical learning. Then finally this paper's conclusions for this. Finally, the conclusion of this new framework for dynamic texture segmentation based on spatio-temporal features. For the spatial mode, we employed a new texture features to categorize each region of a frame of dynamic texture. The histograms of this linear bit pattern and WLT features by this plan of dynamic texture. The temporal mode, we use the optical flow and the histograms of LPP and WLD features. Then dynamic texture to describe its motion field. We also addressed the problem of choosing thresholds for the segmentation framework. We developed a weighted Weber distance measure which is computationally simple. Then and comparison with existing methods, this method is effective. Then the dynamic texture segmentations, our method performs well on sequence with clustered background. Thank you.